consulting segment of our webinar. It's open access to the modeling agency's advanced analytic gurus, senior consultants Scott Terry and Keith McCormick. Scott has not returned. I know he got pulled away, and he is not back, so you'll still be in fantastic hands, by all means, with Keith McCormick. I chime in with a few limited experiences from my side as well. But let's start with a couple of questions here. We're going to start with a more tactical question, I think, that was probably triggered from earlier in the event during Scott's portion. I'm going to keep my favorite question here for the follow-up. So first question, how do we deal with unbalanced data that is most common in our implementations? In other words, the target labels are highly unbalanced. And let me make sure I am muted here. Okay, Keith, you should be live.
Yeah, thanks, Eric. Yeah, this really is common. I would say that it happens about half the time, maybe a third of the time, something like that. So common reasons that you might have unbalanced data would be something like credit card fraud, let's say. I mean, there's a gazillion examples, but when you think of credit card fraud, I think we would all embrace the fact that we don't want our credit card servicers to have half fraud, so it's going to be much, much smaller than that. So what's going to happen invariably is that the modeling algorithms are going to find a pattern that's, let's say, accurate 98% of the time, because they're going to go ahead and say fraud never happens. In fact, if fraud is even more rare than that, your model might be 99.7% accurate, and the model will simply be fraud never happens. So what you have to do is get a sufficient amount of the frauds. And determining sufficient is a mix of art and science, but there are some rules in mind, probably at least a couple thousand as a general rule of thumb. And then you're finding an equal number at random from the other cases. And that becomes the data set that you use for developing things. So a very common critique that you'll get from your colleagues, kind of water cooler talk, is say, oh, well, you've manipulated the data. How can you trust that it's going to work on real data? Well, many of you are probably familiar with the whole idea of having a trained data set and a test data set. So you balance the trained data, that's what you build the model on, but you never ever balance the test data, because it won't be a real test unless the unseen data, the so-called unseen data, has not been manipulated. So there are some variations on the theme. Sometimes you'll meet folks that will balance train and test but not balance validate, which gets more complicated. So anyway, there's some variations on the theme, but that's the basic idea. What you're doing is you're manipulating the training data to be equal size, but then not manipulating the test data, and you're checking to see that the model works on the test data.
Terrific. Thank you, Keith. And I'm going to go on to my favorite question, but let me, boy, I guess I set a high bar here that wouldn't encourage others to put their questions in, but nonetheless, we should have another 5 minutes for another question. Have a little bit of a shy group today, so you've got access to a very seasoned expert here. As we go into the next question, we have room for at least one more, so consider, what's been covered through the event. There should have been some questions raised in your mind. This is your chance to have it addressed live. But let's go on to a very unique question and a great strategic one. I think it's fantastic. Prashant asks, doesn't thinking about the model deployment and implementation in the beginning, this is something that Keith alluded to in his portion, doesn't that kill the creativity and sandbox experimentation that's needed when the modelers may have to throw out their hypothesis many times and begin all over again? So Keith, that's a great consideration. Would their creativity in what many perceive as a discovery process be limited? Did they put some blinders on, or did they put some bookends on what they're going to create with their modeling effort by considering downstream how this is going to be deployed?
Well, I'm as fascinated with the question as you are, Eric, because what's interesting about this is that the basic premise is, if you put constraints on possible solutions, does that kill creativity? In general terms, I would agree. The thing is, though, there are no hypotheses, for one. And two, determining your deployment up front in no way constrains your solution. In the spirit of the question, I think, right? So let me try to explain with a with an example. So I had a insurance company manager come to me once. He was an executive. He was, I think, probably about a VP or a senior VP. And he came to me, and what he wanted to do is he wanted to use data that was being pulled, modeled, and then pushed back to Salesforce.com to rank leads, to help with lead scoring, which is a common application of many of these kinds of techniques. So the basic premise was is you had gold, silver, and bronze leads, and the sales reps were spending all their time on the gold leads, and the bronze leads weren't getting any attention at all. And he wanted to score the bronze leads to encourage the sales reps to reach out. So that was the premise, okay? So what I wanted to do before we began was talk to the sales reps about how they use information that's provided to them now and how they would use information like this. So that's the kind of thing I mean by planning the deployment. How is the model going to be used when it's done, okay? So as it turns out, I asked the sales reps, I just tried to establish rapport so they could be candid with me, and they said, Keith, to be honest, we ignore half the stuff that's in Salesforce.com anyway. We pay attention to X and Y, but we completely ignore Z. So we're having this very candid conversation. So I said, well, what if this new information was provided to you that management wants me to help them provide? Would you pay attention to that? Probably not, is what they said, right? Now I think this is terribly important to know, right? That what you plan on making, the form in which, think of it like a product, right? It's like trying to come up with a feature for a phone, for a smartphone. Does it sound like a feature that the end user wants to use, right? So what they came back with through this conversation, it was very difficult to get this conversation, by the way, Eric and everybody, because the sales reps are busy and they didn't want to talk to some stats guy, But what I ended up finding out is that the reason that they don't talk to the bronze leads, you can guess why. They want to spend their time on the gold leads. But I said, under what circumstances would you get excited about a bronze lead? And they said, well, it's pretty straightforward. We have to know that there's something timely about talking to that bronze lead now as opposed to any old time. That they've put in, some kind of a literature request, or they've just spoken to an inside rep, or there's something going on that makes today a good day to call them. And they said, two, we spend a lot of time on the road. I should have clarified that they're talking to people that they have a wholesale relationship with. So this was the insurance company talking to insurance agents, not insurance agents talking to Mrs. Jones, if that makes sense. So they said, well, if it was on my way home from an appointment, and if reaching out to them today was timely, then that would be fantastic information. And I think the story kind of makes the point on its own in that that's certainly not stifling creativity. You're actually trying to open the floodgates to the creativity, but you're trying to investigate what is the purpose of this model. You're not trying to constrain what the answer is. There kind of is no hypothesis and there is no answer. What you're trying to do is you're trying to craft a process. And the data, once you determine what that process is, the data will lead you there. You're not testing hypotheses. Anyway, I would love to get a follow-up, Eric, on that, because I was as fascinated with the question as you are. But that's what the process feels like. I hope that was helpful.
Yeah, no, that was, and Prashant's already responded back, said, thank you for the answers, very helpful, 3 exclamation points, so enthusiastic response. Thank you both for the question and the great response. And it sounds a bit like, preparing your landing field, you know where you're going to land. You may have to change course at some point and look again. I mean, this is, I guess it goes a little bit into kind of agile development, but in between is plenty of room for all the creativity as you had expressed. I love that question. So thanks very much, Prashant. And we do have time for one more. This is from Rajit, and the question is, how do I choose, and I'm sorry, Keith, I meant to give that to you ahead of time. How do I choose between different algorithms, for example, logistic regression, random forest, neural networks? That's a very active discussion. That's more of what we go over in that model phase. It's more of what you would expect from the most of the courses that are available out there. So that's method selection. And you might not be surprised after today's event to understand that much of the information that's going to drive your method selection is acquired upstream. in the assess and plan phases. And I'll tip my hat that much. I don't want to get greedy and start to lead the answer. But Keith, what would you say to Rajit about method selection? What's your advice?
Well, first I want to thank him for the question, because it's actually a great follow-up to the question that we were just talking about. And it's so timely coming in on the heels of the other one, right? If you went in with an attitude, oh, maybe we'll build a logistic regression model. Oh, gosh, that didn't work out. Maybe we'll try random forest. Oh, gosh, that didn't work out. Maybe we'll try neural net now. That would feel, I think, like the spirit of the initial question, right? This notion that you have like a hypothesis, or you're going to try something and it doesn't work out, and then you go back and you're going to feel like you're spinning your wheels, right? Well, that's not really how the game is played. What really happens is when you get to the modeling phase, you have survived, or at least you think you've survived the data prep phase. Often you have to circle back and, address this or that. But, when you finished it and moved on to modeling, you're largely finished the data prep phase. So this is like champagne time. This is like the hard part of the project is over. You're like, woof, I survived the worst of it. I feel like I was been dragged behind a truck for 6 weeks, and now I finally got in the modeling phase. So it's kind of a celebration. And if you have set up the data properly, and if you have done a proper job of defining the problem space, is kind of a geeky way to put it, then from there, it's trial and error. The hard part's over. You've carefully defined the problem to solve the business challenge that you're facing, right? So now, this is the kind, this software finally comes to the rescue at this point. You're trying not just one logistic or one random forest or one neural net. You're putting on, you're probably even looping through different parameters and so on. So when you get to the modeling phase, it's celebration, because it's the easy part. You just try them all. And that's not, I was just going to say, Eric, that's in no way wiggling out of the question, because that is the answer to the question. You don't choose. To choose would be to constrain the solution space, which you don't want to do.
Right.
You want to try them all. You try every algorithm at your disposal.
And based upon what you do collect and assess, and of course that's going to guide your planning, are there some methods that are going to be less applicable? For example, can you, with the few minutes we have left, talk about some of the general functional behaviors of some of the algorithms? For example, there will be trade-offs between accuracy and explainability, and decision trees are very explainable. At the same time, you might look at it. I know genetic algorithms are not that popular anymore, but they're very computationally heavy, but they can often find more globally optimal solutions or heuristics, whereas neural nets are not as computationally intensive, but they can get caught in local extrema. And logistic regression, very efficient. It's a little less black box, perhaps, but I guess going along with.
No, I'm with you.
I was going to. One other quick point was, Einstein always said you want to use the most simplistic algorithm possible to solve the problem, and only go up to the point that you really need that sophistication. We don't want a Maserati for city driving. So that's the end of my point.
Well, I'll make two quick comments, because now you're getting into territory where that's certainly a big topic. But for instance, I was on a project recently where the nature of the project was I only had 526 rows. That's, as you know, very rare in this kind of work. But I'll give kind of a medical metaphor. It wasn't a medical project, but basically it was a situation where maybe I was trying to start with a bunch of oncologists looking at x-rays. And since the human oncologists were looking at x-rays, I only had 526 of them, if that makes sense. That kind of metaphor, right? So in other words, human evaluation was generating the practice data, and I wanted to build a model that imitated that, that knowledge, if that makes sense. So out of the list that Rajit offered here, probably logistic regression might be the only one that I'd have a chance, because it's the only one that would be able to work with about 500 cases. But, you really have to be pretty experienced before you start picking winners, before you go in. Really the best, unless you're a real pro at this, really the best behavior truly is to try them all. But, it's interesting, just the way you were characterizing them, because we both been in this space many years, as you know. You mentioned like genetic algorithms and other, approaches that go in and out of favor. Like look at neural nets. It's kind of in its third renaissance all of a sudden with deep learning.
Right.
I mean, 50s and then 70s it was completely out of fashion. Then 80s it was hot, and then 90s somewhat out of fashion again, and now it's hot again, right? So these go in and out of fashion. There's a book that's come out over the last year or so called The Master Algorithm, and it's basically one chapter on genetic and it's one chapter on neural. And, he talks about the 5 tribes, and the whole notion of the master algorithm is maybe in another generation we'll have a single algorithm that has the advantages and disadvantages of all these different approaches. But at the moment, we're still, probably for the next 10 or 20 years, we're still in trial and error mode. You try them all.
Well, we are, and I should write a book called The La Brea Tar Pits of Modeling Algorithms, because they do, they suppress for many years, and then they just resurface. You see them again, along with a lot of the buzzwords. Some of them do traipse off, thankfully, and don't come back, but others that have merit, they're tried again. I think they often fall victim to strategic blunders, not so much tactical ones, and because they, you can't really do without them, particularly a lot of the analytic algorithms, they resurface, sometimes under different names, but it's funny how machine learning's also returned.
One final point, Eric, that's
Sure.
so important, because you set it up for me. I have to take a swing at it. What people don't realize at first, perhaps, right, depends on their level of experience, is that in typical settings, not the 526 rows story that I just shared, right, but in a typical situation, logistic regression, random forest, and neural network are going to be within approximately 1% or 1.25% or 0.75% of each other. They're not going to be radically different from each other. So the battle is won and lost during data prep. By the time you get to modeling, you're fighting over this last 1%, So if you've done a lousy job at data prep, you've left 3, 4, 5% of accuracy on the table, and now you're fighting over 0.75%, right? So it's not about the modeling algorithms, it's about good data prep.
Yeah, it is, and let me queue up another for you, which is, I guess, two different things to look at. One is, when you've done your planning, there might be some other constraints. And we were talking about real time earlier. There was only 10% who chose real time, but there may be a real time consideration, and processing speed of at least the recall of the model, which is far less computationally intensive than the training, still may be a consideration. What's the way that we can come out with a model that is as efficient as we need it to be if there is a real-time constraint? So there may be other environmental issues that can sway what you're going to choose. But here's the part that I'll queue up for you. There are various automated packages out there, and Scott in his segment gave his warnings about using packages that are overly automated. But I think it would underscore your notion that so many of these algorithms, they train in very different ways, but they still arrive at, within the range of 1 or 2% in model accuracy. And you can watch these train a neural net, train a logistic, and you see these lift curves go side by side, and they're all very close, and you can pick the one that's most accurate. But here's what I'll queue up for you as we go over time a little bit, is that, model accuracy metrics don't necessarily directly translate to your business performance metrics. What would you say to that? That we can take a Honda and sometimes do better with that than getting your Porsche optimized and running it 5 degrees off course.
Let me answer. Obviously, you and I just talked about this. You know how I feel about this, but I think but you've kind of set me up with a challenge here. How can I, in about 90 seconds, kind of summarize my thoughts on this for everybody? But I think the easiest way to think about it is take things like, let's say, weather data or text mining. A lot of folks were intrigued with unstructured data and so on. A lot of times people will ask, oh, well, should I do text mining? Well, I think everyone potentially could benefit from text mining, but the way that I set up text mining could not be more straightforward. Build the model without unstructured text. Find out how accurate the model is. Then add the unstructured data like text, and the accuracy will go up a certain amount. There will be a delta that you can measure. You should be able to translate that into increased return on investment, and it either pays for the text mining or it doesn't. And I don't necessarily mean that once somebody's using a commercial package, it could simply be someone's labor that you're trying to recoup, okay? But it's really as simple as that. All of these projects should be self-financing. So should I try fancy technique X or should I try fancy technique Y? It's simple. Do the algebra and figure out if fancy technique X or fancy technique Y will result in a return on investment. Sometimes they do, sometimes they don't. So I'm agnostic on things like text mining. I've had good luck with them, but there are times that I do the math. They're not going to pay for themselves, and wait until later on in the future of that project where maybe parameters change.
Yeah, and the biggest thing is framing the problem and how you're going to measure the effects of those, and that's what we don't see that happen very often. So before I go into the webinar wrap-up, I'll give you one parting comment from Prashant. If you want to respond, certainly do so. I think it's more of a parting comment here. Prashant says, thank you, Keith. Just for the context, when we talk about planning and development, we get into the IT conversations, and it becomes less about concepts of modeling. We're making sure the business goals and analytical problem remains the priority during conversations with IT.
Oh, I don't know. I think if you do the conversation successfully, you don't have to run afoul of that too much. I think, but I think what will happen, and it should happen, it's a good thing, is that sometimes your number one project becomes second place, third place, or even fourth place after everybody sits down together, and the complexities of the problem from the IT side push it out of first place. Because again, you have to take everybody's labor and everybody's investment in technology and factor all of that into cost before you can guesstimate ROI. So it's quite appropriate that the IT team and their interfacing with the problem could push it out of first place or first priority. And I think that's quite appropriate.
Yeah, and there's a lot of project qualifiers that come into place for that, where we see an organization has 3 or 5 projects in mind, and boy, it's good to kind of educate the leaders and stakeholders to come up with additional ideas that may be important to them, because if we can get that up to 15 or 20, those are many of them are going to be deprioritized or even disqualified, and we're back to 3 or 5 that are now valid. And now, how do we prioritize those for what will be lowest risk, highest impact? So great questions, fantastic responses. For a smaller group, and the questions that we had coming in here ended up being, I think, a highly productive Q&A. But at 38 past the hour, we better draw this event to a close. Certainly like to thank our attendees today for your sustained interest and your active participation in the polling and the Q&A, as well as Scott and Keith for your great presentation segments, and Keith for the highly informative Q&A contributions. That was fantastic. We'll follow up with an email shortly with some resources and suggestions that will hopefully be useful to you. And Rajit, hopefully you wrote down the resource you mentioned, Keith. Could you repeat that? There was a source
the book. Yeah, it's he's done a TED video as well, the author of this. But the name of the book is The Master Algorithm.
Oh, great. And I guess an Amazon search will find that. You don't necessarily need.
Sure, I'm sure an Amazon search or Goodreads or anything like that should yield more details on that title.
Okay, fantastic. So, like I say, you'll get an email shortly after, in a couple of days, with resources and suggestions, and from there we'll hope that you'll consider joining us at a public classroom event or live online training event soon. So make sure to go to the website and check out the schedule and the details for the upcoming productions in Seattle in July, the live online experiential courses in August, and then Washington, D.C. in October. On behalf of myself, Scott, and Keith, thank you again for attending Predictive Analytics Failure to Launch. Have a very pleasant afternoon and evening, and this brings the webinar broadcast to a close.